Well, good afternoon, everyone. We are now approaching our second last keynote for our two-day conference. Welcome back, everyone. I hope you did find the panel previously just on building a culture of disruption advocacy with Stuart, Catherine, and Dan very, very informative. We're going to take a bit of a different this time. I'd like to call up Raj Vasa, who's the head of Translational Research and Development from Deakin University, to a bit of an interesting topic, which no doubt you've all heard of, but probably don't, like me, have a great understanding of, at least at this stage anyway, and that's a conversation on AI. So Raj, I'll hand over to you, mate, and away you go.
Thank you, everyone. And thank you for the opportunity to present. I'll go through, there's quite a few slides, but I'll go through it fairly quickly. And at the end of it, I think you can pose questions and we can have a chat at that point in time. So this is the content I plan to cover in the presentation. Just gotta try and see if I can go full screen and still retain control. Yes, I can. So this is what is AI? Why is there excitement? Some of the recent works. We're going to reflect on the AI methods. What are the warnings? And some of the lessons learned. And eventually, I'll try and get into the ethics. I'm going to try and go through it fairly quickly. So get ready for the ride. So what is AI? I won't read through all of the slides, but I'll go through some of the key points. So this is a definition that we tend to take. There's many things, but the easiest way to think of AI is just a machine that appears to be intelligent. It's not really intelligent if we take out the human side of it. And do they work? Sort of would be the general idea. So this is the kind of reasons why it gets hyped. So that girl, the picture that's generated of that face is completely made by a machine. So this person doesn't exist. So you can go to that website and it will generate a whole range of faces, human-like faces for you. So if you're into modeling and or Hollywood, there may be some impact, but in general, these are not mature. And if in doubt, just look carefully at the ears and the nose, and you can see there are gaps in the way the machines guess. So they're also getting into this making up things, so they can make words up as well. These words don't exist. The machine is just making them up based on reading an entire dictionary. Great if you want to just have a bit of fun with kids. This starts to look a little bit more promising, but not quite. So this entire conversation is also generated by a machine. The machine was just fed heaps and heaps of documents, and then it said, okay, learn patterns and then make me an interesting story. So what we tend to give is the very first line of that paragraph, and the rest of the information generally gets picked up by the machine, and it'll just make it all up. So if those of you that know who Cantor is and into mathematics might find the joke there. They can also generate things that are a little bit more sort of interesting, and they can learn patterns, and they miss it carefully. You start to realize it's mostly just gibberish that it's put together. So what exactly can it do for me today is a top question that a lot of people ask. So the first, this is a list of things, and it's easier to understand with an example. So, and the best example would be a self-driving car, because everyone thinks they're going to be there any day now. Maybe in the next 10, 15 years, we might see some of this slowly start seeping in. So there is a camera that will classify objects that it sees. There is some detection of the lanes going on. It's learned from driving behavior of thousands of drivers that have driven this car with data collected about them. It'll try and optimize for road conditions. It'll try and do all kinds of calculations for it. There is Google search, map search going on inside it. There's a whole lot of rules that we made up about how fast we should go on different roads. It'll try and adhere to that as best as it can. So in this example, you can kind of see it's guessing light poles, roads, and so on and so forth. So this comes from NVIDIA, a company that makes hardware that we use for AI systems, making AI systems. And will it be there? Like I said, maybe 15 years, we should start to see more of this. It'll seep in slowly as part of the safety systems that we're starting to get in modern cars. Will there be complete self-driving cars? Maybe in some places, but unlikely, broadly speaking. And so again, some people are curious. So this is mostly for the people that are curious as to, so how are these machines actually made? So we teach it by showing it lots and lots of examples. So, and there are two things it needs to do for a self-driving car. It needs to detect the traffic sign. Then it needs to say, okay, this is the speed at which I have to go. A long time ago, we used to just make all these rules up. So we used to then give lots of photos and manually analyze color and do all that. So this is about 10 years ago, 15 years ago. This is how AI used to get built. Last 5-7 years, there's been a breakthrough. So we don't have to write any of the rules. We can just show it a lot of images and say, go figure it out. It'll figure it out, but it makes mistakes. So all the data that I showed you just there, it does matter a lot, but there is a big caveat here, is the machines don't know what that data means. We have to give it meaning. So this is the water level in Melbourne Dam. And the standard question is this enough to forecast what the water level will be, say, in 2 months' time, right? The machines don't know what actually causes the water level to rise or fall. It just, if this is the only piece of data it's got, it'll guess from historical data, and it'll probably get the seasonal variations okay. But the actual part that rainfall data is needed is not something the machine will know unless we give it that. So that's the kind of stuff that humans still have to provide. Theoretically, if all the data went into it, there is people that would say, well, it'll figure it all out eventually. But we're not quite there yet. And machines don't know. I mean, if I gave it car sales data and said, this is what causes rain, it'll probably just use that to make the predictions. It doesn't know. The other thing with AI is if I asked it a question like, will it rain in the next 3 hours? It can say 3 things. The issue is it doesn't know why a human asked that question. And if the intention was to paint the fence or intention is to water the garden, that matters a lot in how much information it should provide to you. If the intention is to paint a fence, the certainty of rain, how much rain, all these kind of things matter. Watering the garden, similar, but the context is slightly different there. You may not want any rain when you're fence, whereas even a little bit of rain might be adequate for the garden. So it depends a lot. This information is not often inside the brain of the machine. So we have to hand hint a lot of this when we build solutions. Another common question, will AI take all of our jobs and will we be out? Not all jobs, a small percentage of jobs, maybe. And the primary reason is these machines are not that good, and they won't get good unless a human engineers a lot of issues. And I'll show you examples of that shortly. Before I do, I'll just explain what we as an institute do. So I run the translational research group at the Artificial Intelligence Institute. So we're about 100 people. Most of us are professional data scientists, experts in building AI, and software engineers. And people come to us to build solutions for problems they face. So we come out and we do it. So I'll show you some examples so you can then come back. So this is a real photo from the Alfred's trauma unit. And if someone has an unfortunate accident, they will end up here if they're seriously damaged. And so there is a system here that guides the decision-making process of that group of people. And we're looking to see if they have forgotten something, and we hint them to say, hey, it looks like you've forgotten this. How it does is from every possible venue possible, and nurses are providing some input to it. And based on all of that, it'll give some guidance. You actually can't see the system. It's actually slightly out of the photo frame. There's a big television that kind of beeps and prods them. They glance at it when they need it. And this is roughly what it looks like. And it's actually saying, yep, something like that. The red and the things at the top right is what it'll blink out at. And people do use it. And it's in use in 3 hospitals globally right now. And we're going to slowly span it out to more. We worked with IWF a little while ago, a couple of years ago, to help predict which email they should read first. So when customers are sending lots and lots of messages, you want to read messages from the grumpiest customer or the grumpiest high-value customer first, things like that. This uses a combination of techniques, both machine learning and rules and understanding the domain quite a lot. So the context of how we decide matters a lot. Last year, when the pandemic was in full swing, we did a system to learn how a clinician decides whether to intervene or not. So this was used in Melbourne, and it's currently going out to be used in US. They're a bit late, but they have finally selected us. So it's slowly going to get used. For the next pandemic, we'll be very well prepared to let people recover at home, and we should be able to keep an eye on them quite at a low cost. We've got another system that we worked with for ESA that recommends what learning resource that a teacher should recommend to a student. It takes a lot of inputs. Based on that, it'll make a recommendation. So this is currently rolling out to be used across Australia. We're working with Defence and a few other people to look for defects in carbon fiber materials, helicopter wheels especially. This is a big project we have going on right now where we want to try and find the most effective treatment with the least amount of data and information we can get. So again, as you can see, these are very highly specific, targeted, carefully calibrated machines or solutions. And we have to do a lot of work to hand hint all these things into things, at which point in time it starts to become very powerful. This is TED, and TED talks to people who care, nurses mainly, to teach them. So TED has virtual dementia. So TED mimics the behavior of someone with dementia or a person living with dementia. So the nurses can train with TED without having to deal with, before they go and deal with an actual environment. And it's significantly different once they've interacted with TED, so they learn a lot. So again, use of AI in a non-traditional sense. There's systems we've built that are used across museums to provide useful data so the machines can guide them a bit better and analyze what displays are working well for them, why they're working well for them, and things like that. There's another system we did last year as part of 2020. People couldn't come in for rehabilitation work post an operation or post a heart attack, for example. So we built a system that allows people to exercise at home while they wear a polar heart tracking machine or a biomonitor, and then we detect anomalies. Then the nurses can support like 10 people at the same time remotely. So this is rolling out across a lot of hospitals right now. Number of years ago, we did a smart home that allows people to stay at home. This is now quite an old style of technology, but back when we did it, it was all cutting edge. We have systems that are in use across the university systems for students to help them learn a bit better. So predicting congestion. So you would have seen that AI is amazing. So this helps defense forces decide when they're planning for missions and things like that. So I'll quickly go through it. The main philosophical approach we take is that we start with what you want the machine to do, rather than I want to have lots of data, I want to learn something from it. I'll go to the more interesting part now. So this is the warnings, and this is really the gist of what the topic is mainly about. It's like why all this AI has to be done carefully. So first rule is if we as humans cannot do something, we have to ask, can a machine do it? And even if the machine does do the task, how do I know it works? I mean, it is difficult. If someone comes to you, and we've had examples where farmers have come and said, oh, we want to know if my cows are happy. And our question would be, can a farmer tell if a cow is happy, independent of data? And the answer is no. Then how would they know that our machine is working, our AI is working? And there's variations of it. Machines can speed up humans a lot, but if they can't easily do things we cannot do at all. And even if it did, we don't know if it works. It's very hard to know for some algorithms whether the machine is working or not. So we need to have a clear definition of it works for me and it will be useful for me in my business context. So I'll give you an example of this AI. So there is an elephant in the room. In interest of time, I'll point out it's in the top left-hand corner. And the AI has labeled it as a chair with 60% confidence. Now, the reason why this happens is that when we teach these AIs, it has never seen an elephant in a room. You would have seen an elephant inside a forest. The context in which an object appears is what it learns, not just the object. A classic example, this has come last week, is I can cheat now that I know how these machines work. And this would be quite a disaster if the self-driving cars and the self-driving cars use the exact same technology that's being cheated at here and exploited. So I can take an apple and write toaster on it, and everything, the AI will think it's a toaster. And I can take a chainsaw and just put dollar coins on it, and it'll think it's a piggy bank. Big issue, not easy to fix yet. The data itself isn't enough. I mentioned this earlier as well. It doesn't have meaning by itself. We need to have a model of reality. We need to make a lot of assumptions. We have to provide all the context, and the machines can't reason without human support. So we have to do a lot of hard work to give the machines some structure in which they actually operate. Machines will go wrong. And because it's AI, I can guarantee you that it'll make a mistake. So I have to design it for failure, always, from day dot. Mostly, there's a lot of confusion between is AI a feature or a function, right? In most cases, AI tends to be a feature. It's very rarely the core function of a system. And the example that I've given up here about a car and a cup holder is hopefully helpful. So the value of AI sadly can only be determined after I've built it. So this means that some form of prototypes have to be built, put it into production use, and that's when we know whether it's useful and working. It's very difficult to build probabilistic systems and be sure that they'll be acceptable to the end user. Moving from prototype to full production is very, very time consuming. So what we can prototype in months can take years before it's useful in production environments, especially if a business wants to be sure that it can help them save money. So these things take years to develop and slowly roll out. So so therefore it limits who can take advantage of AI at this point in time. The standard software development methodologies or digital system development methodologies don't work for AI. We need to have very different protocols for measuring efficiencies and effectiveness. We need to put it into production-like environments and pilot them in real use cases as early as possible. And if there is a bug and it doesn't work, I may need more data to retrain it, which means that the whole life cycle repeats. This implies that I have to ship early prototypes into production. That means I have to train the users to say, be ready, because I may be giving you something that's imperfect and I need your feedback to fix it. And if I hide all of that, I'll limit what I can ship. The total cost of ownership is quite high for AI. It takes longer to build, it's more expensive to test, expensive to run. People that build these things are very expensive. And there are risks that are hard to quantify. So businesses should be very mindful before they put AI in, or work with good teams that actually slowly bring them up to state to use it. So it's not as straightforward as I'll roll out. I mean, we struggle to build and roll out good accounting systems and do change management at scale already. AI is incredibly hard to get right at scale. I mean, the very large companies do it and they make it look easy, but behind the scenes, there's a lot of work that's gone in. So the key point is, given all these warnings, you can do AI, but you need to be clear what it will add as value and focus on the business case and the robustness. Otherwise, you have a high risk of producing a cute prototype, getting everyone excited, and not delivering business value. In case it looks scary, all those slides and saying that this might be a helpful way to think of it. A quick wrap up on around ethics. Given all these gaps that we have into testing AI and making sure we can build it. So this is the list of people that say, in humanities people, they'll say, well, these are the ethical principles that I have to have in AI. The hardest part is if you take it to an engineer and said, I want my AI to have dignity, or must respect, and it must be fair, and it must be accountable, etc., etc. Most engineers will come back and say, no problem, I'll give you a respectful AI, just define respect in a mathematical form that I can measure. And if you can't measure it, then it's very difficult to build computations around abstract, fuzzy concepts. If humans struggle with it, machines struggle even more. And that goes back to a point I said earlier, which is, if we cannot do it well, machines will suck even worse. And on top of it, we also have the human problem that all the things, the data so far we have, they are actually trained by systems that were created in odd ways at a time when people were not thinking about it. And this is about 10 years ago, Stanford started a process to label photos. And on the left-hand side is the hierarchy of labels that they made up. No one actually questioned them at that time, because nobody actually thought about AI at that time in serious detail. In the environment we live now, these are starting to be questioned, and the people are asking, it's like, who makes these labels up? Why is those labels even there? And who decides that label is associated with these photographs? And the machines are allegedly able to tell our emotions. Almost all emotion models are trained on these 6 facial features made by six Japanese actors made all of them, 40, I think, or 60 images, and then that's what's learned from. So it's very limited. And that's it. Time for questions.
Outstanding, Raj. Thank you for that amazing keynote. Probably one quick question from me, mate, if you wouldn't mind entertaining. Obviously AI is a very kind of hot topic at the moment, but I suppose a lot of our delegates here today come from either small to medium enterprise. Is there an entry-level way into harnessing AI, or is it, I suppose, a case of sort of putting all your eggs in one basket and going big?
It's the maturity of the technology is not suitable for many smaller organizations right now. Even if you worked with, say, university labs and got something going, you will struggle to maintain and manage it because the skills needed are very expensive right now. So you would be better off partnering with products or solutions that are encapsulating some of these AI elements into it already. but I wouldn't recommend building from scratch if you're an SME. It's quite a high risk unless your core business is providing AI services.
Understood. And is there a when those SMEs are looking to, I guess, outsource or effectively partner with an AI vendor or technology partner, is there certain sort of checks and balances that they need to kind of adhere to, or what should they really be looking for in a
the kind of warnings I mentioned, the warnings that I mentioned would be good to be aware of, that there are lots and lots of limitations, and good to ask hard questions. Don't be sucked in or enamored by the cute things. Ask hard questions, and in particular your business value. If you can't clearly articulate business value and you can't see business value, don't go into it. Not yet. It will become mature in the next near term and more accessible for the SMEs. But right now, having worked with a lot of different companies, people who can tolerate long timelines and have slightly deeper pockets will be able to do it. But it will be more available in the next 4 or 5 years.
All right, fantastic. Well, look, that's it's a very good segue, Raj, because our next panel will be by Scott Wall, Agustinus, and Sandeep, who will be going into, I guess the topic is called "I Was Sold the AI Dream." So it's understanding the ethical AI and capabilities which can be afforded by intelligent automation to any business. So that, as I mentioned, it's a great segue. So Raj, thanks again for your time today. Thank you. I would ask everyone to please hit the leave button and just jump into the next session, which should kick off a little bit after 2:15. Thanks again.
So